Okay, so we're at 1-6, solving multi-step inequalities. Okay, this is very similar to solving equations. We're still going to use our 4 steps. Anybody remember what the 4 steps are?
It is simplify, divide.
Simplify is the first one. What's the second one?
Isolate.
Collect the variable on both sides, then isolate, and the last step is divide. So you can think of it as skid. That's one thing, okay? Simplify. Each side if possible. Collect variable on one side if it's not already on one side. And then third step, isolate. Somebody said that. Isolate what? Isolate the variable. And then last step is divide. All right. So let's go ahead and read the problem. The math club members are selling Pi Day T-shirts. Anyone get that? Pi Day is March 14th. Pi Day 3.14. So the math day, they want to have a mathy T-shirt. Pi Day T-shirts for $7.50 each. The goal is to raise $500 by Friday. The figure below shows how much they have raised by Wednesday. Okay, you see the figure below? How much have they raised?
They have raised $7.50.
No, that's how much they're... Yeah, the figure below, $337.50. So they've made most of their goal. Not all of it, but they've made a good portion of it. Okay, so what is the minimum number of T-shirts they must still sell in order to reach their goal? And explain your reasoning. Okay, so any ideas? What are we looking for?
We are looking for the minimum number of the T-shirts.
Very good. Minimum number of T-shirts. Pick a letter that you want to represent that.
X. P.
It can be any letter. I heard X first. I'm going to say X.
D.
X equals the minimum number of T-shirts. And what's different about this is it's not just the number of T-shirts, it's the minimum number. So if the number is 5, that's the least it could be. It could be 6, it could be 7, it could be 8. It can be that or anything bigger. Minimum number of T-shirts. Okay, so what do we need? We need to figure out, first of all, how much money do they need to make to get from $337.50 to $500?
Isn't it $7.50?
Did somebody subtract that in the calculator? Put that in your calculator and tell me what you get. How much money do they need? Somebody put in 500 minus $337.50.
It's like 200.
162.50 cents?
Yes.
162.50 cents. So that's how much they need in money to make, right? So we know that we have $7.50 a T-shirt, right? Times how many T-shirts? X. That's the minimum number of T-shirts. And it's not going to be equals this time. This is an inequality. Okay, it's not equal. It can be greater than, less than. We got to figure out what symbol makes sense. Okay? So they need to make $500 or more. Would it make sense? This one or this one or this one or this one? We have less than. We have greater than. We have less than or equal to. Greater than or equal to. Which one of these makes sense for our situation?
What makes sense?
Okay, so somebody said the third one, this one. So that means we want to make $500 or less. Does that make sense? We want the number of T-shirts to buy to be a certain amount or less. So actually it's not that one. It's going to have to be one of the greater thans. What if we make exactly our goal of 500? Is that okay? It is. So the equal part's okay. So it can be greater than, it can also be equal to. So 7.50 at $7.50 times the number of T-shirts, that total, or that answer to that needs to be greater than or equal to $162.50. Now I could have written the equation 500 minus this on the other side and then combine the terms. I just did this over here on my own just to make my inequality simpler. Now what do I do next?
We will divide.
Yeah, this $7.50 is being multiplied by the number of t-shirts. To get x by itself, we do opposite math. We divide both sides by $7.50. Somebody in your calculator, do this for us. Put in $162.50, divide it by $7.50. Make sure you put your decimals in.
21 or 22.
Yeah, tell me the exact number you got.
25.
25? I don't think it's 25.
No.
It's 21, 6, 6.
Yeah, exactly. So the actual mathematical number is this. X is greater than or equal to 21.6 repeating, right? You have a bunch of repeating sixes.
Basically 6.
Now think about what makes sense in the situation. Can you really, and remember, this is the number of t-shirts. You can have 21 t-shirts. Can you have a fraction of a t-shirt? Can you say, I'm just going to rip this t-shirt in half and sell it?
No.
Probably not. So actually, this is the exact amount we would need to make it, but in real life, it would actually be 22. Do you see that? Because if we round down to 21, it's going to be not quite enough money. It's going to have to be 22 for it to be reasonable.
So we round up.
So we're going to say X has to be greater than or equal to 22. 22 t-shirts. And we're going to see a little bit more of that when we do word problems. You have to get your mathematical answer, but then you have to ask yourself, does that even make sense in my situation? All right? So what's the minimum number of t-shirts they have to sell?
22.
They have to sell at least 22. Is it okay to sell 23?
Yeah.
Yeah. So any number bigger than 22 is okay. But any number smaller than 22 is not okay. 22 exactly, that's okay also. Make sense? Okay, so that is an inequality in a word problem. Let's look at just some regular math inequalities, just the math. Take out all the word problem stuff, make it easier. Okay, so we're going to do 6A, we're going to do problem 1A. We're going to do that right now. But I want you guys to work ahead, and I'm going to be asking you what to do. Okay, so I'm going to rewrite it. We have negative 6A minus 7 is less than or equal to 17. The only reason I rewrite it is to make it bigger so I can work with it. If you don't want to rewrite it and you want to start right there, that's fine. Okay, I'm going to go ahead and make my wall. Okay, I want to find the variable. Where's the variable?
The variable is the 6A. Negative 6A.
Yeah, the A is right here. So we can't simplify. There's nothing to simplify. It says the C in skid is collective variable on one side. It's already on one
So
side.
do we have to isolate?
Now we're going to isolate the variable. So we put a box around it if we want. So everything that's on the left-hand side that's not in the box needs to move. So what do I move?
You move the negative 7.
And how do I do it?
You put a negative 7 or plus 7 under the 7, and you put a plus 7 under the 7.
You're exactly right. We move this by inverse operations, also known as opposite math. The opposite of taking away 7 or a minus 7 is plus 7. That cancels out, which is exactly why I did it in the first place, so it'll cancel out. What is 17 plus 7? 24. So over here I have 24, and over here I have my negative 6A.
Negative 6A, and then you look at the little sign with the thing.
Yeah, notice, this is not an equation, but everything we're doing is the same steps we learned when we did equations.
So basically like the first week of school. Right?
Yeah, the first 2 weeks of school. What kind of math is happening with the negative 6 on the A?
Well, you have to get the A by itself. So.
But you're right. You're getting ahead though. What math? Is it adding? Is it multiplying? Is it dividing? There's no plus sign. It is being multiplied. So remember, whenever you have a number and letter together, and they're just connected without any add or minus symbol, they are multiplied. Remember, they're best friends. They're glued together by multiplication. What is the opposite of multiplying? Now this part I want everyone to pay close attention to, because I know this is a review for everybody, but this part I'm about to show you is not review. This is new.
And it would be 1/4.
We're dividing by negative 6 on both sides. 24 divided by negative 6 is negative 4. So over here we have A, but here's something that is new to today, unless you had a really good teacher that's taught you extra stuff last year. With inequalities, remember this is not an equation. We do not have an equal sign. We have greater thans, less thans, all that stuff. This one is a less than or equal to. Whenever you divide both signs by negative or multiply by negative, you flip the sign. And somebody said it, and you are awesome. Okay? This less than or equal to is actually now a greater than or equal to. Okay? That is the only, when you're actually doing the math, that's the only real new thing. I mean, we're interpreting the answer differently, but when you're actually doing the math steps, that's the only new thing, is you have to flip that symbol if you divide or multiply by a negative. Now, the other new thing is when you look at the answer. Is the answer negative 4? Yes, because of the equal to, but it's also any number that's greater than or bigger than negative 4. So it could be 0 is bigger than negative 4. 5 is bigger than negative 4, right? So all those are part of the answer. Anything smaller than that are not part of the answer. Make sense? All right. Let's do B, and then you're going to do C on your own, and we're going to check it in a minute.
And then we'll do the volunteer.
Yes, we'll do some volunteering. Okay, B is negative 4 is less than 5 minus 3n. I'm going to make my wall here where the symbol is. Okay, let's go through the skid steps. We simplify each side. There's nothing to simplify. There's nothing to simplify. We collect the term on one side. There's already the variable on one side. It's right here. We collect the variable. We're going to isolate it. Now, raise your hand. Tell me what I put a box around. And be very careful. What is it, Lauren? Say it again. I didn't hear you. Something with the 3n. What is it else, Alejandro?
It's the minus. Yeah,
the 3n's right, but it's the sign that goes in front belongs to it also. Okay? It's a negative 3n. That negative does not belong to the 5. Is the 5 positive or negative?
It's positive.
Okay, it's a positive 5. So you have a positive 5 term and a negative 3n term. So the opposite of positive 5 is negative 5 on both sides.
Negative 5 and negative 5.
Now, somebody raise your hand if you can combine these correctly and give me the answer for this part.
Wait a minute.
Over here. Negative 4 and negative 5.
Wait, we add subtract.
Very good. He said you're going to add them because they're the same sign. They're both negative. You add them, and they're still negative, negative 9. Remember, when you're dealing with these numbers, yes, they're small numbers. But if you have any doubt, or even if you don't have a doubt, for now, at this part of the year, you might check in the calculator, because integers will be rough with you if you are not getting the signs correct. Okay, that's negative 9. Okay, so we have negative 9 equals negative 3 times n. What's the last step? Yeah, we do flip the sign, and he's a little bit ahead. Why do we flip the sign? Because we're dividing both sides by negative 3. Since you're dividing by negative, you flip that less than to a greater than. What is negative 9 divided by negative 3?
Negative 9 divided by negative 3 equals 3.
Yeah, a negative divided by negative is positive, and we know 9 divided by 3 is 3. So 3 is greater than n. Now, there's two ways you can write the answer. We usually like to have the variable on the left side. So notice, you see the n? You see the alligator biting the 3? You could switch the whole thing around. As long as you still have the alligator biting the 3, both of these answers say the same thing. You're saying the 3 side is greater and the n side is less. You read it differently. This says 3 is greater than n. This one says n is less than 3. But they both mean the same thing. Okay? It'd be like saying, I have less money than you, or you have more money than me, right? You're kind of saying the same thing, just approaching it from a different direction. Okay, I want you guys to try C on your own, okay? And then we'll come back and we'll talk about it.